Greetings and much blessings to you, geometry students. I want to make a video which will, I trust, help in your preparation for your upcoming test, whether it's tomorrow, Friday, or Monday. So God, I trust you'll guide us and you will open our understanding and help that this time will be fruitful in Jesus' name. Okay, I'm going to start with the verse, which great verse I gave you, which gives wise counsel about your heart as you learn. And it says, I trust you remember, you can just say it with me, and you got it written down. It says, keep your heart with all diligence, for out of it spring the issues of life. Say it with me. Keep your heart with all diligence, for out of it spring the issues of life. And then a few questions from the lessons. I gave these to you on the handout, and I've got a few here that I'd just like to go over with you. We're told that we got midpoints here. So A is a midpoint. Therefore, this distance AX is the same as AY. And this distance YB, or from Y to B, is the same as from B to X. And finally, the distance from C to Z is the same as the distance from X to C. All these are the same. So this is a mid-segment. AC is a mid-segment. BC is a mid-segment. And also AB is a mid-segment. And I trust you remember, even from the quiz you took, that BC is going to be not only parallel to the third side YX, but it's going to be equal to half of it. So if YX is 70.2, then BC would be a half of 70.2. What would that be? That would be, you divide it, you get 35.1. Okay? And also I said it's parallel to it. So you could actually put an arrow here and an arrow here, indicating that BC and YX are parallel to each other. We'll come back to that. What else do you want us to find? I want us to find the distance from X to C. So from X to C, this little distance here, which is a half of XZ. But since AB is a mid-segment, whatever AB is, if you double it, it's going to be equal to XZ. So since AB is a half of XZ, then AB should be the same as XC. So this right here, XC will be the same as AB, which is 32.4. All right. In addition, I might say, or I should say, that AB is parallel to XZ. So I can actually put a double arc here on there. Let's see another one here. And it's parallel to the third side here. The mid-segments are always parallel to the third sides. And that leads us into 30. I got XC here again. I don't know why I have it twice. Shouldn't have it twice. Not sure what that should be, but 33, so the measure of angle BCX. Where's BCX? I'm going to put on R here. BCX. BCX is this angle here. And this angle here is going to be the same as this angle right here. Why? Because this is parallel to this. This is the transversal. So these angles, this one, BCX, and this one is just 42. They are alternate interior angles. So B, C, I said X, it should be Z. BCZ is going to be 42. I trust you can see that. Alright? So, I'm going to write that in and leave the rest for you to think about with the parallel lines and so on. This is 42 degrees. Okay, so you can think about those and seek to do those yourself. Let's go to another one. 37. It says write the sides of triangle ABC from shortest to longest. So this is triangle ABC. I hope I have it right. Let me look and see. Maybe I have the letters reversed. Let me go back. I think this should be B. Let me look again. Yeah, this should be B right here. Can I change it? I think I can change it because that's going to influence how I name these. So this should be C. And this is what you have on the handout. So from shortest to longest, the shortest side is going to be opposite to the smallest angle. So the smallest angle here is a 43-degree angle. So the shortest side would be this one right opposite it, which would be BC. It's going to be BC. And I don't know how to do the bar line, but you should put a bar line over the BC because BC is a segment. Then the next shortest is going to be opposite to the middle-sized angle, which is 46. So opposite to 46 will be this one, namely AC, and then the longest one will be opposite to the largest angle, which is this, and that side would be this one, AB. Okay. Similarly, there's another question 38. They give you the angles, they give you the sides rather, and the shortest side will be opposite to the smallest angle. Similarly, the longest side will be opposite to the largest angle. Okay, so you can work on that one also by yourself. Let's go to the next page. In this page it said find the value of x, give the answer in radical form. So let's take a look at this one. This is a righteous triangle. They give us the leg. One leg is 6, one leg is 2, and it's important for you to identify the hypotenuse. I'm pretty sure you can. Which would be the hypotenuse? The 6, the 2, or the x? I trust you'll say that it's the x, the hypotenuse, which is the one opposite to the largest angle, which is the right or righteous angle. So we've got c squared is equal to a squared plus b squared. Which I could write better with this. I think I forgot my pen at school. This is going very slowly. Anyway, this is the a, this is the b, this is the c. So the x squared is going to be equal to 6 squared plus 2 squared, according to the Pythagorean theorem. 6 squared is 36. 2 squared is 4. So x squared is equal to 36 plus 4, which is, what's that? 40. And now x will be equal to the square root of 40. And they ask us to report the answer in simplest radical form. Do you remember what that is? That's going to be looking for two numbers which when you multiply them together, you get 40 such that one of them is a perfect square, and the highest possible perfect square. So you look at 40, so what can I do? 4 times 10 is 40, and 4 is a perfect square. Can I do anything else? I think that would be it, because 20 times 2 is 40, but 20 is not a perfect square. 2 is not a perfect square. So the best we can do here is to say this is going to be the square root of 4 times square root of 10. The two numbers we choose should be such that 1 is a perfect square. 4 is a perfect square because 2 times 2 is 4. So your answer here would be square root of 4 is 2, and 10 you leave as is, because 10 is not a perfect square. And you can't simplify 10 anymore. You could go 5 times 2, but 5 is not a perfect square. 2 is not a perfect square. So this is going to be the simplest radical form right here. Okay? We're going to leave this one for you to do. Slightly bigger numbers, but you can do it and work it down to simplest radical form. How about the next grouping here? Find the missing side length. Tell if the sides form a Pythagorean triple. I want to see if I can work this one through with you. But before I go there, the Pythagorean triple would be 3 sides that make up a triangle such that they're all whole numbers. Whole numbers. These wouldn't be a Pythagorean triple here because this is not a whole number. This is a decimal. A decimal or a radical or a fraction, it can't be a triple. These could possibly be a triple if x comes out to be a whole number. So let's see what it would be. We'd say x squared, which is the hypotenuse, is equal to what? Is equal to 24 squared plus 32 squared. Oops. It's a fancy 3. This is squared. Alright. I want to go to my calculator. 24 squared. I think I know that 24 squared is 576. 576. 32 squared. I don't know, so I'm going to find it now. 32 squared, that's 1024. And I add those together. I get 1600. 1, 6, 0, 0. That's x squared. So x will be what? X is going to be the square root of 1600. And I'm sure somebody is just showing me. I know what that is. That is 40, because 40 times 40 is 1600. That would be exactly right. So this will be 40. And so the 3 sides of the triangle would be 24, 32, and 40. Would those form a Pythagorean triple? Yes, because they're all whole numbers. So yes to the triple here. Alright? No to the triple here, but you could find the third side here. You'd have to use your calculator. Okay. Next page. Tell if the measures can be the sides of a triangle. That's the first thing. And then classify the triangle as acute, obtuse, right? Okay, this one should be fairly easy. Sides of a triangle. We take the oops, no, not that. Yeah, sides of a triangle. The sum of any two has got to be greater than the third. So we do 9 plus 12. 9 plus 12. We get a number which is 31, and 31 is greater than 16. So that would be a check. When we do 12 plus 16, we're going to get 38, and 38 is greater than 9. And finally, 9 plus 16 will give us 25. 25 greater than 12. That's a check, so we can say yes. And as I see the time running out, you do 16 squared compared to 9 squared plus 12 squared. If it's equal, then it's a right triangle. If it's greater than, it's an obtuse triangle. And if it's less than, it would be acute. All right? God bless you.